How would you tell them why AGI matters today?
Whenever you want to run AI in the real world, you're running it on the edge. A lot of the IT workloads, I would say, are still very cloud focused, but the OT, the operational technology, is really where edge AI is happening.
What do you think is the most pressing challenge right now that is slowing down the adoption and deployment of AGI solutions?
I think one of the challenges that's in the AI space in general is data set quality.
How has the evolution of hardware for AGI come through from MCUs with accelerators to NPUs to domain-specific AGI ASICs? Where do you see this progressing, and who do you think will win in the next 3 to 5 years in this sort of hardware race for AGI?
There'll always be general purpose compute. I mean, you can run AI models on a CPU. You could, probably burn some calories there, but you can do it. But we're going to see more and more specific hardware tuned to the model architectures that'll give you like much higher tops per watt and tops per dollar, frankly.
As they say, it takes a village to deploy an AGI solution. So it's all about
That's it.
collaboration and yeah, not about competition per se. Hello, everyone. Welcome to the first episode of the Ambient Insights podcast. I'm your host, Saharsh, and our guest for today's episode is Pete Bernard, president of the AGI Foundation, which is focused on advancing the mission of efficient, scalable AGI. Pete has over 30 years of experience in Silicon Valley, Microsoft, working across edge computing, 5G, AI, IoT, semiconductors, and has a wealth of knowledge and experience on everything edge AI. He's rightfully a voice of authority on the topic. So, welcome to the podcast, Pete.
Yeah, great to be here. Great to be here. Good to see each other virtually. I know we saw each other recently in person in Taiwan. So
Absolutely. Yeah, it was a pleasure meeting you in person as well, and I'm glad to have you here virtually too. So, just for the benefit of our listeners who might not be very familiar with what the AGI
mhm.
Foundation is, do you mind giving us a quick overview of what the AGI Foundation does?
Yeah, I mean, kind of, it's really it's the world's largest community of edge AI developers, technology makers, and academia. So we're a nonprofit. We are community driven. We're really focused on the acceleration of edge AI, the technology itself, the business, as well as the education of it to the population. So we've been around since actually 2018. We used to be called the Tiny ML Foundation when we were first founded by Evgeny Gusev and a number of other folks. And about a year ago, we rebranded as the Edge AI Foundation, just because of all the new conversations and technology that was out there.
Yeah, that's super interesting, and we'll circle around back to that just in a minute.
Mm.
And as a member of the AGI Foundation ourselves, we can totally attest to the amazing value that you add to the community. Um, So, you've spent time across lots of different fields, working in several companies in the Valley, working at Microsoft. So, if you had to give us a short origin story on what got you obsessed with AGI and how you landed up as
Mm.
the president of the AGI Foundation, what would be some of the key chapters of that story?
That's a good question. I mean, so I graduated with a degree in computer engineering at Boston University, and I went in there as a software kid and really got hooked on hardware, electrical engineering and circuit theory, and so when I left, I really was fascinated with this kind of hardware software boundary. Where does software become hardware and vice versa? And got a job as a BIOS engineer at Phoenix Technologies outside of Boston, writing firmware, and then moved west, Silicon Valley, and did work there for them, and then left and did a series of startups and small companies, kind of around that space. Embedded Java, radio firmware, all kinds of things. And then eventually made my way up to Microsoft, where they were building this Windows Phone platform. I think they called it, or Pocket PC or something. They had some names for it. And worked on that. I was one of the first folks working on the Zune music player up there, if people remember that. And a bunch of things where sort of hardware meets software. So that's always been my thing. And then probably I don't know, 7 or 8 years ago, we started at Microsoft looking at AI. I mean, AI has been around forever, right? But originally it was like, well, how do we run AI workloads, on silicon? I think we were calling it Edge AI back then. I'm not sure. It was like part of the Azure team. And we started looking at that. And that was just fascinating about how you could, run AI workloads and models in these kind of resource constrained environments. I did a bunch of that stuff at Microsoft, and then I left in 2023. Still fascinated with the space, and had been doing some work with nonprofits, and then was approached by Evgeny, who is the one of the founders, and they were looking for someone to take over the organization and kind of grow it into
Mhm.
what it is today. Um, and so that was a really good fit for me because, like I said, I was into the tech, and I get to work with really cool companies like Ambient and other folks who are doing cool things with hardware and software. So it kind of all worked out.
Yeah, so that's super interesting how you say that, Edge AI is one of those small subsets of compute where hardware truly does meet the software. And we'll definitely talk about this more in detail as we go on.
Yeah.
But it's one of those subsets of compute where you really have to either optimize the hardware for the software or the other way around. One of them has to sort of happen in the current state of the technologies available to us for Edge AI.
hmm Yeah, well, I think it was the what was the famous quote? I think it was Richard Kay said, "If you're serious about software, you need to build hardware." And truly, when you get down to the bit level, they're very similar. It's just you can't recompile hardware, but other than that, it can be
Yeah,
pretty close.
yeah, absolutely. And in the beginning, you mentioned how the AGI Foundation was previously known as TinyML. So
hmm
what changed in the ecosystem or the industry where, you felt
Yeah.
that TinyML was no longer capturing the full essence of what the foundation is now trying to do?
Yeah, well, when I came into it, I mean, the conversations were already expanding. We had the
Mhm,
Chat GPT moment, I think, in 2022. We had a lot of Edge AI vision going on, CNNs and RNN
mhm,
models. So things were already sort of spilling over from the kind of microprocessor based TinyML conversations from the community. And so it was sort of like, well, how do we be more inclusive and understand these things. Because also, as you know, these things never exist in a vacuum. It's never
mhm,
just a chip
right,
and a model. It's
right.
always a solution that involves lots of things, including the cloud, right?
Mhm,
And so we just started to think more holistically with the board and with some of the leadership about how do we redefine the organization to sort of think more holistically about AI and what we call in the real world. That's kind of our tagline,
mhm,
right? Connecting AI to the real world where AI is running in things around you. And some of those things can be, NVIDIA Jetson powered or 17-inch rack mounted powered, on prem.
mhm,
But some of them also can be in sensor, So I sometimes use the phrase from sensor to server
mhm.
as kind of our world there. But that was kind of the evolution, really following what the community was interested in talking about and developing, and then how do we create, a framework and a set of programs and investments to accelerate all of that.
No, that absolutely makes sense. And even from our perspective, since the rebranding happened, since you started calling it the AGI Foundation, it just became a lot more
Mhm.
relatable for the end users, suppliers, companies like us, anyone who's interested in the ecosystem, because a lot of the models, a lot of the applications now actually are AI models and not just ML or machine learning. So that definitely
Mhm.
did make a difference. That small change in just how you present yourself.
Yeah, and part of it is too, like you said, there's people out there trying to apply this AI to their business now,
Mhm,
right? Municipalities, for security and safety, agriculture, farmers, healthcare, manufacturing, automotive, mobility. I mean, a lot of people are trying to apply this stuff. And so, we wanted to be a place where they could come and learn about it from all the technology partners we had in academia and really figure out how they can make it work for their business, which, ultimately accelerates things for everybody.
exactly. And I'm going to pick up on one small thing you said just a little while ago
hmm
is that the Chat GPT moment happened a few years ago. Was
hmm
that in any way a catalyst for the mission of the foundation, or did that sort of make the foundation rethink its its journey, its direction in any way?
Well, it certainly brought a lot more attention to the area of AI. I
Mm,
mean, you can almost argue, I wouldn't say too much attention, but there's been a lot of public
mm,
education around AI. A lot of people think AI is just ChatGPT or chatbots,
yeah.
right? And so we sort of tried to leverage that energy to educate people about this broader topic of an edge AI as kind of a part of the AI landscape. So it certainly has brought a lot of energy, a lot of dollars, a lot of investors. You know, we have a lot of VCs and investors and corporate VC as part of our community as well, looking for the next thing. And so I think it's been super helpful. I mean, technically, we actually have a generative edge AI and agentic edge AI working group.
Hmm.
We do a lot of work there to explore what's the state of the art, you know, small language models, crazy small language models, you know, agentic interfaces, MCP, A2A, things like that. So there's a lot of good tech work happening to make sure that those types of model architectures run really well at the edge.
Hmm.
Um, but yeah, I think back then, I mean, it wasn't that long ago, a few years ago. It sort of, you know, I don't know what the metaphor is. It sort of poured a bunch of gasoline on the fire, I would say.
Oh, that's the perfect way to capture it because it definitely brought an insane amount of attention to AI. But
Hmm.
from our
Hmm.
perspective, a lot of times we have customers or users who approach us and they ask us, "Can I run LLMs on your chips?" So not all of that
Right.
attention has been positive, but
No, and that's
definitely
part of
helped
the
the
education.
case. Yeah.
Or at least they're asking. At least they're
Yeah,
asking.
true.
Like you know, engage them in the conversation. And you know, and one of the things we're seeing too is a lot of, and we've always been. I've been a believer in this. It's always been like a series of AI models working
Mm,
together, right, from cloud to edge. So you can have models working in the sensor that's sending metadata up to something else, and that's using AI for some other part of the solution that's being managed by the cloud, where maybe you're training models. And so, you know, connecting generative edge AI or generative AI to edge sensors is definitely a hot trend these days.
yeah, absolutely. And on that note, for some of our users who may not be completely familiar with what Edge AI is, it may still be sort of a buzzword term for them, or
Mm,
some of the skeptics out there who think, okay, why bother with Edge AI? Cloud is fine for me. It's running my applications just fine.
sure.
How would you tell them why Edge AI matters today? Why should they reconsider their approach or think about what kind of benefits Edge
Right.
AI can bring for them?
Yeah, no, that's a good question. I mean, you know, like I said, our tagline is connecting AI to the real world.
Mhm.
So whenever you want to run AI in the real world, you're running it on the edge. And there's a very important place for the cloud in that as well, especially on the training side. You know, time series insights, data lake analysis. A lot of the IT workloads, I would say, are still very cloud focused. You
Mhm.
know, like the meeting minutes and email and all the classic IT stuff. But the OT, the operational technology, is really where Edge AI is happening, right? And the telemetry and the analysis. And I mean, you think about a car going down the highway, you're not going to be sending your camera feed back to the cloud to
Mhm.
say, "Hey, should I turn here?" You know, it's
Right.
happening in real time,
Right.
and so, and whether that's the farm field or in healthcare, you know, you want that low latency, you know, low power, high impact AI, and that's one of the real benefits of Edge. I mean, one of the we use a term called blurp,
Mhm.
BLERP, which is kind of a funny name, a funny word, but it's bandwidth, latency, economics, reliability, and privacy,
Mm.
and those are sort of the key value props of edge AI. And obviously, you know, it varies depending on your solution, but in general, you're running AI for lower cost, lower power, and more impact when it's on the edge.
That's interesting. I think I'm gonna use that acronym quite a lot now going forward.
Blurp.
Yeah, so thank you for that. But even if we, let's say, think about some of the applications in the real world. So let's take a
Mm.
very specific example of predictive maintenance. A lot of it
Hmm.
still happens in the cloud. Someone would argue that it's totally in the real world. All the sensors are, on site on the actual machines. But hey, why do I need Edge AI? Why can I not do it in the cloud? And a lot of the arguments you
Right.
made still hold true in terms of the privacy, the latency, reducing the bandwidth, economics, and so on. But yeah, I mean, just the
Yeah.
point is that there are still lots of applications in the real world where the skeptics would argue that, the cloud is just fine for me. It's working perfectly
Yeah,
all right.
and in some cases, the cloud makes sense. A lot of times, that's part of the equation.
Mhm.
And but there is also the economic argument. In some cases, you have to analyze. Every solution needs to fit inside of an ROI envelope,
Right.
right? So, do I want an OpEx tax where I'm paying cloud, for
Mm,
every AI workload that I run,
mhm.
cloud taxes for putting data in, for taking data out of the cloud, or do I want CapEx, where I invest and it's running locally, and there's no tax.
Yeah.
So that's another kind of economic argument that people make, and also there's just the connectivity stuff. I mean, I've worked in connectivity for a long time. Having reliable connectivity to the cloud can be very challenging in a lot of real world environments. Let's put it that way.
Mhm.
Um, and so, kind of using the connectivity for the metadata as opposed to the real data. I mean, an example is if you have a pedestrian safety camera somewhere, you're not streaming that image somewhere to the cloud to see, oh, has someone stepped off the sidewalk?
Mhm.
No, you
Right.
have to do it there. The cost of sending all that data and the connectivity required is ridiculous. So in many cases, you just can't run these scenarios unless they're on the edge.
Right. And you bring up a very interesting point again, is the debate between the CapEx versus the OpEx. And
Mm,
in most of the scenarios where we also come into contact with customers demanding solutions or wanting, something ready-made off the shelf, what we're
mm,
learning is that the capex required for edge AI solutions really is higher than um, uh, an average user would want to engage with. So why do you think it is this way? Is it just because edge AI as a field, as a domain is still nascent, and there's not as many, plug and play modules, like off the shelf algorithms that developers or
mhm.
users can use, or and will this get streamlined over time from your vantage point?
Yeah. And it depends on the capex budget is really dependent on the solution
Mhm.
and how long is that solution going to be deployed over time. I mean, typically in the commercial space, it's years, which can add up.
Mhm.
Projects always start on the cloud. They start on the cloud because you do your proof of concept and you do your models and your weights and you kind of figure it out, and then you move it to some sort of real world platform as it gets more commercialized. People usually start with a very high performance platform, like they'll start
Right,
put it on an Nvidia Jetson box, right? And then they'll realize, okay, that's very hot and expensive. So can I actually do this for a tenth of the price
right,
and run it on battery? And then it gets into like more edge stuff. Um, but that's really kind of the calculation that you have to do. I think as with anything within the tech world, semiconductors and hardware platforms are getting more capable on a daily basis, and
right,
the price per price per tops and price per gops and tops per watt keeps coming down on a daily basis. And
right,
so,
right,
things that cost X 6 months ago are, a fraction of X now. And so that's just going to keep happening. And so I call that the gravitational pull of the edge. Like workloads migrate, they just migrate over time to where the data is created. That's just
right.
physics. That's a law of nature that you cannot fight.
I like that.
So
Yeah,
you really need to embrace that and figure out, how do I run AI workloads as close to where the data is created as possible. And yeah, you're right. It has to be done in an economic envelope where there's a good return on investment.
right, right. So out of all the different edge AI deployments and the real world scenarios and use cases that
Mm,
you've seen working with so many different companies at the foundation, were there
yeah.
one or two any particular use cases that stood out to you and made you, gasp, okay, this is, why working on Edge AI feels
Mhm.
valuable and satisfying to
Mhm.
me, and this is truly the power of Edge AI.
Well, it's always good to see impact, locally. So when people can deploy edge AI solutions and like vastly improve their agricultural yields or their water quality
Mhm.
or safety and security. We had a live stream. It's on our YouTube channel. We have live streams every other week. We actually have a show every week now. We had someone on there from a city in Colorado who had a problem they had a bit of a drug problem, and they had people wandering into the streets in the middle of the night. And so they developed this pedestrian safety camera system I was mentioning before that would alert drivers that someone was in the roadway,
Mm,
um, and so that people could put the brakes on, right? And you can imagine that had to happen in real time, you know. And it was also they were solar powered too, so they were low
right,
power, so the deployment cost was effective.
right.
Didn't cost 100,000 to put a camera up; it just basically connected to a pole. And that was great. And they showed real data that said, "Hey, we really reduced, you know, injuries and fatalities." Um, and they also mentioned, you know, unfortunately, when those types of accidents occur, obviously the person getting hit by the car is that's the person that's getting injured, but
Right.
also the person that's driving the car is traumatized.
Yeah,
So, you know, seeing like that's a scenario that just couldn't have happened. You couldn't have that solution, you know, without Edge AI. So it's really cool to see things that have real tangible improvements locally when we see these deployments.
absolutely. And I think as a company, that's something that drives us very deeply as well. And we also focus on working on solutions, applications that can drive some real world impact. So, for example,
Hmm.
we're working on our fall detection wearables that would be useful for the senior folks. We're working on
Yeah.
denoising for hearing aids, where you these applications and solutions do need to be at the edge. They just wouldn't work
Hmm.
with some sort of a cloud connection, or if you were dependent on an connectivity network or anything. So
Yeah.
I'm completely aligned with you in terms of, Edge AI really
Yeah.
does have some real world impact. It's just about finding
Yeah.
those use cases and applications where they really shine.
Yeah. I mean, we actually just finished. We have a series called Edge AI Challenges, where we have worldwide competitions. We had almost 400 people competing in the last challenge. It was called Earth Guardians,
Mm,
so it was all about coming up with solutions for environmental sensing, you know, wildlife detection and preservation, and people came up with incredible things to detect forest fires and tracking elephants and all kinds of things. And then that whole area is getting revolutionized with edge AI, like self powered, low power AI in the field. And then the other thing you mentioned too about fall detection, there's this whole theme around kind of I call it aging with dignity. So how does technology help people in their homes stay in their homes longer, safer, whether that's fall detection or even self-driving vehicles, all kinds of things, and measuring their health, anomaly detection for their health, where their doctors can be looped into situations. I think we're going to see all of that kind of revolutionized with Edge AI coming up.
absolutely. And on that note, do you see any particular industries, domains where you think Edge AI could have serious impact, but it just happens to be underutilized for whatever industry challenges or whatever
Hmm.
ecosystem challenges?
Well, probably one of the biggest places it's sticking first has been in the manufacturing space. So you imagine defect detection is kind of a no-brainer. So we're seeing some really impressive kind of high-speed defect detection systems for manufacturing,
Mm,
where they're using AI vision to really, you know, improve yields and quality. So that one's straightforward. I would say agriculture as well is starting to get rolled out. And again, agriculture is traditionally in the big farms, it's obviously pretty high tech, but
mm,
in bringing that down so that everyone can benefit, we're starting to see that as well. And then the other thing that's interesting is in retail. So most people don't know this, but like quick serve restaurants, fast food places, they use a lot of tech, and they're
mm,
using a lot of more and more tech on not only the food prep, for freshness, but food quality and safety. Detecting, how what's called dwell time. How long are people waiting to get their food? How long does it take to clean up the table after someone's left? Counting cars in the parking lot. All kinds of interesting applications there. So the
mm,
next time you go to your Taco Bell or whatever, you might want to think about, wow, there's a lot of tech happening around me to get my burrito or whatever. But we're seeing a lot of infusion of edge AI tech in sort of retail, hospitality, food services, and things like that. So and it's all happening. It's all
mm.
happening on a daily basis.
Absolutely. I love the agriculture example you gave because we know about applications like soil monitoring and pest detection for crops
Mhm.
and so on. But for a lot of these industries, the edge AI adoption is happening a little slower than, some industry analysts would have predicted, let's say 5 years ago and so on. And a lot
Mm.
of it boils down to the various elements that you need for an application to be successful. So there's the
Right.
hardware, there's the ecosystem support for the AI algorithms, the rest of the embedded software, the actual prototyping of the PCB, and so on. And I know that
Yeah.
the Edge AI Foundation is doing a lot to make it easier to deploy these kinds of solutions. But from your
Yeah.
perspective, what do you think is the most pressing challenge right now that is slowing down the adoption and deployment of Edge AI solutions?
Yeah, well, you're right. It has to be deployed by solutions. We have more and more solution providers that are members of the community, and those are the folks that are really stitching together these solutions for these verticals, right? So they go in and they sell it into the agricultural market solutions or into retail, and they develop, design, and deploy solutions that includes maybe someone else's hardware and chips and software, but they stitch it together. So the good news is there's a lot more of those folks out there than there used to be, which means there's people out there. If you're a business owner, an industry, there's folks that know your industry and can help you do that. I think one of the challenges that's in the AI space in general is data set quality. So you have to train a model on a data set. So imagine if you're a manufacturer, beverage manufacturer, right, and you want to use AI to detect defects in your cans. Um, you need to train that model on a can data set, right? Of all kinds of can types and dents and pull tabs and all kinds of stuff. Where do you get that data from? Because the quality, if you don't have a good data set quality, your model's not going to be trained well and your results aren't going to be good. So that's one of the things, and we have a data set working group that's actually trying to help industry improve quality of data sets, right? And we actually provide data sets for free on Edge AI Labs on our website for people to get started on those things. So that's one thing I think is improving because now there's more tools. So now people are building tools. This is what happens in the tech world. When there's a problem, someone starts building a solution. So how do you manage data set quality and improve data set quality? So people are actually using generative AI now to create data sets. We actually just released a generative AI based data set for cans on Edge AI Labs, which is free for non commercial use. Um, we have a partner called Synthetic AI Data, which is part of the community, and that's what they do. They create data sets out of generative AI. So I think we're going to see more and more high quality data sets out there, and that is really the thing that unblocks a lot of these deployments.
Yeah, that's super relatable problem that we initially ran into as well. And we think about it slightly differently is we call it the generalization of the edge AI algorithm
Mm.
problem is, you can train the algorithms on a small data set for sure. But when you try to
Mm-hmm.
go and deploy them in the real world scenario where there's infinite degrees of freedom and infinite variables,
Sure.
that small data set just doesn't hold up in the real world anymore.
No.
And just like you
Right.
said,
You're going from.
we went ahead and invented our tool as well to sort of solve that problem, which is a small tool that just lets you collect data directly using the sensors on our development kits boards and labels it automatically for you, which very partially addresses the problem, but it still leaves
Mhm.
the bigger problem open, like you said, is where do you get good data from? And
Yeah.
in your experience,
Yeah.
looking at these synthetic data providers, um, does
Yeah.
the synthetic data set is it able to match the quality of data from the real world? Does it actually lead to AI algorithms with good accuracy, or is it more just like a stopgap uh,
No, I
temporarily?
mean, I think that's definitely the wave of the future. It's an interesting artifact of generative AI is that it's helping, edge AI and smaller models with data sets. So if you, the synthetic AI data folks I think they're out of Copenhagen, but there's a number of companies like that's their business now, and they're building tools and capabilities. So you can imagine like if you did self checkout and you're trying to recognize a head of broccoli, right? You need a data set of broccoli heads. So we're
Right,
not going to go out and
right,
photograph broccoli. Like, doesn't make any sense. So,
right.
so you can synthetically create lots of variants of heads of broccoli, and then the thing becomes way more accurate. I mean, you talk
Right.
about hundreds of thousands, millions of heads of broccoli. So I think it's definitely the way of the future, and the tools are getting really good. I mean, we have synthetic AI data. I mentioned Edge Impulse. Lots of companies, Embed UR, lots of companies in the community are building these data set uh, tools, management tools. I don't know what the category name is going to be. There's another company called Voxel 51 that I like. Um, and it's all about how do you create high quality, you know, data sets that you can manage and use to train your models. And in some cases, you can imagine like if you're a lumber facility or a tree cutting facility, I don't know what they call them, but you need very specific data sets around like recognizing grains of wood and things like that. So
Mhm.
that stuff has to be created and has to be high quality. And like you said, yeah, I wouldn't say anyone, but pretty much anyone can do a POC where you can show your boss like, hey, look, it's a hot dog or not a hot dog, right? I mean, that's
Right.
kind of the old joke.
Right.
But like deployed in the real world, there's a lot of different hot dogs out there. So
Right.
that is one of the challenges.
Yeah. And we actually manually recorded and created our data sets to create the fall detection solution. So you can imagine how
Yeah,
painful that might have been.
yeah, it's tough. Well, like these environmental solutions from the Edge AI Challenge recently, like detecting wildlife sounds. A lot of interesting stuff in audio AI, by the way, that's out there too. So how do you use audio and to do detection of breaking twigs or crackling flames or different bird calls and things like that. So yeah, how do you collect all that data and then train models on it? It's very interesting.
Absolutely. And yeah, it's interesting to hear that now there's synthetic data AI companies there. There's even a lot of other AI companies I see who are just actually going out there collecting these kinds of data sets and making it available for
Hmm.
people. So as a problem arises in the market, someone comes up to sort of solve and address the problem, which is the
Right. Someone
beautiful
fills
thing.
the need.
Yeah, exactly.
Yes.
So, now let's switch gears a little bit and I want to talk a little bit about hardware because that's a pivotal aspect of AGI, like you mentioned. The hardware has to meet the
Mm-hmm.
software, or the software has to meet the hardware at some point.
Yeah.
And from your vantage point, how has the evolution of hardware for AGI come through from MCUs with accelerators to NPUs to domain-specific AGI ASICs? Where do you see this progressing, and who do you think
Yeah.
will win in the next 3 to 5 years in this sort of hardware
Mm.
race for AGI?
Yeah. Well, I don't think it's a winner take all market. So, first of all, I think actually the diversity of our community is a feature, not a bug.
Mm,
Um, and that enables solutions to be deployed all over the place. So that's the good news. If you're on the hardware side or on the semiconductor side, there's lots of opportunity there. But over time, I mean, if you really take a step back, compute hardware has gone from general purpose, processors to more and more specific processors over time, right? We started with CPUs, and we went to GPUs. Actually, we had floating point kind of
right.
calculations. Remember those things? GPUs, NPUs. Now there's like LPUs, like language processing units, right? Sparsity processing units, all kinds of interesting. So over time, like the compute hardware gets more and more specific to the workloads if there's enough scale around the workload, and so that's kind of the trend. So we're going to see more and more, hardware acceleration for AI that's more specific to the model architecture over time. So I'm convicted on that. And there'll always be general purpose compute. I mean, you can
Mm,
run AI models on a CPU. You could,
mhm,
probably burn some burn some calories there, but you can do it. But we're going to see more and more specific hardware tuned to the model architectures that'll give you like much higher tops per watt and tops per dollar, frankly. So that's where it's all heading. And so I would keep an eye on companies that are really innovating in the semiconductor space on sort of model specific acceleration. And that's been, we started up at the MPU space, and now we're moving into MCUs and even farther out into sensors. And then we're seeing the rise of, I mean, there's still x86 stuff and ARM stuff, but now a lot of RISC-V is very hot in this low power
mhm.
space. So in the low power edge, a lot of RISC-V based architecture being used and paired with acceleration, AI acceleration.
Right.
But again, it's not a winner take all space. There isn't going to be an Nvidia of edge AI. I don't think so. And Nvidia is already in the space with some of their Thor and some of their other chips, which are really cool. Um, but again, it's like I think in the British say horses for courses. So depending on what your solution is, you should find the right hardware, that's going to fit that scenario and also fit the economic envelope.
Right. 100% agree with you. And if you just look at the nature of AI compute, it's just so different from what general purpose compute used to be. That was more
Hmm.
instruction after instruction for a huge variety of tasks versus AI compute is extremely matrix multiplication, very vector compute heavily driven type of operations. And of course, as a company, we also sort of moved in that direction of building AI native architecture and making sure that,
Hmm.
we can actually accelerate AI compute efficiently. Um, but the interesting thing that I'm seeing now, increasingly, the sort of narrative is that there are two camps now in hardware. There's one camp which
Hmm.
is the new architecture for AI native compute, where the product makers and the chip makers build their own tools, their own ecosystem for their specific architecture. And then there's the
Hmm.
other camp, which is more focused on okay, open source architectures like ARM and RISC-V, which everyone's already familiar with. There's an ecosystem built around it, a lot of plug and play libraries, APIs, and so on. So there's a
Sure.
bit of trade-off in both the camps, right? In the AI
Yeah.
native
Absolutely.
architecture, there's um, the skill required to sort of get up to speed with a new architecture maybe makes the time to market a little bit slower. And then on the other
Hmm.
side, it's much easier, much faster to build the applications, but then you're sacrificing some of the benefits, some of the raw performance, power efficiency
Hmm.
benefits that you could get from specific architectures. So what's your
Yeah.
stance on, where do you fall within these two camps, and what do you think will
Yeah.
eventually win over in
Well,
the next few years?
yeah. I mean, all soft coming from a software developer background, I would say all software developers want the hardware to look the same, right? Because it makes their life easier.
Yeah.
But if you're a hardware developer, especially in like in a nascent area like this, like and I've been involved in standards efforts for a long time. You don't want to standardize too quickly, right? Because you miss out on the innovation. And I would say we're still very early in this space in terms of the right architectures. And I mean, even people will say like, well, transformer-based architectures for language models are like super inefficient, and someone's going to come up with a new architecture that doesn't require a nuclear power plant for every data center, right? So
Right.
we're still at I would say, the steam engine era of AI in terms of efficiency, right? And so
Mm.
we don't want to rush into, well, everyone has to do it this way, just for the sake of, it's tidy and easy, and miss out on that innovation. So I'm a big fan of sort of like, let's like let a lot, like a thousand flowers bloom and see who comes up with the right stuff. Now, the onus, like you said, is if I'm building a cool chip with a unique architecture, I have to build the tools and the compiler and all that
Right.
stuff, and I have to snap it into PyTorch and Onyx and all that other stuff. So, but and that's a cost, right? But that's the cost of maybe being innovative in your architecture and being a leader. So it's a matter. It's a function of time. Eventually, things will settle down, and people will start to use more standardized platforms and things. But I think it's still the early days in many cases, and so it makes it challenging and an opportunity for a lot of tech providers in this space to create differentiation and to innovate and find a you know build a better mousetrap, rather than snapping into when I was like in Microsoft. I spent a couple years in the Windows org, which is classic. Like, here it is, like everyone knows what it is. It runs on
Mm.
this, and I was involved in a program, driving this program called Windows on Snapdragon, where we were putting Windows on the Qualcomm Snapdragon
Mhm.
chip, which was kind of Windows on ARM, but kind of the newer stuff. And that was interesting, but I got a taste there of like, wow, like when things really do standardize, arguably calcify, it's a different world, and we're not in that world right now.
Yeah.
So things need to play nice. A lot of people develop on CUDA, so you're thinking about, well, if I do it on the cloud and CUDA, how do I move that to the edge? I mean, there's a lot of interesting work happening there. But I'm a big fan of like let's just innovate and build a better mousetrap and make it snap into the ecosystem, right? So that other people can use it, obviously. But I think we're pretty far away from any kind of real, hard standards.
Yeah, and this whole debate around standardization has a, a lot of weight associated with it as well, because
Mm.
if you're a developer and you've designed some algorithm already for a specific architecture, let's say you've built it on CUDA, and now
Mm-hmm.
your management or your product team tells you, hey, we're switching to a different chip, to a new architecture. It's such a huge
Yeah,
problem for the developer to then go and figure out, okay, do I have
it
to
is.
rewrite my model completely? Is there like a converter for me? So how important do you think
Mm.
standardization is to make edge AI deployments more widespread, more successful today? Or do you think that that just sort of will happen over time and there'll be
Well, there are
initial?
the good news is, yeah, like we were saying before, if there's a need in the market, someone's going to try to fill the need. So there are companies now coming in with like compiler solutions to move models, what I call model munging.
Mm,
And they're using AI in their compiler technology, frankly,
interesting.
to make good choices. Yeah. So you could say, well, I want to move it from, so you started on the cloud and maybe you had it on a Jetson CUDA, and then your boss said, actually, it needs to be 1/10 the price. So please put it on this NXP, whatever, or whatever the chip is. There's tools out there. We have companies like Yasp and Roofline and Zedek and SqueezeBits and all these folks that do this stuff where they build compiler technology now to move models to different platforms and to optimize those models. So again, if there's a market need, someone's going to fill it. I'd rather see that than everyone say we're only going to use this one chip. You know,
Right.
that's that's not fun.
Yeah.
Um, so I think that there's tools out there to do it, and frankly, this is interestingly AI is helping with some of that coding and some of that optimization and portability. So that developer who then got that word from their boss to move this model to whatever, well, there's stuff out there, there's code out there to help them do that, which is cool.
Yeah. Yeah. What an interesting world we live in right now, where
Yeah,
AI is helping edge AI become more easy to deploy across the whole
yeah.
lane.
And those are opportunities for startups too. Lots of startups are innovating in those spaces, right?
Mhm.
Where, maybe if you were a giant, you know, big tech company, it might not be worth your while. You might
Right.
have some tools, but for a lot of these smaller companies, they're really innovating. A lot of them are spin out of universities too. That's why we do so much with academia. Um, we do a lot with our scholarship funds and EdgeAI challenges and working with educators around the world to bring academia and industry together because not only do a lot of startups spin out of academia, but there's just a lot of great research, uncommercialized research happening in the academic space for AI. So
Yeah.
pretty cool.
Yeah. Interesting. And the whole standardization angle has another piece to it. So there's, of course, standardization of models, model porting, but benchmarks often happen to be another topic of debate, because in the
Mm,
AGI community, there's not too much consensus on how you measure the power for the models that you're running, how you exactly measure the AI performance. Is it usable tops, or is it, the peak theoretical
right.
tops, or is it the power
Yeah.
consumption of the AI core or the whole processor? So, and I know that the Edge AI Foundation is also putting in a lot of effort to sort of make
Mhm.
these kinds of benchmark standardization. But what's your viewpoint on, the
Yeah.
industry coming up with the common set of frameworks to make it more standardized across these benchmarks as well?
Right. Yeah, I mean, so we do support and contribute to the ML Perf efforts. We consider them sort of the benchmark police, and as a community, we provide input to them on that. And there are some efforts in the tiny space to do some more benchmarking. There's also efforts like Neurobench for neuromorphic computing, where we have a working group contributing toward Neurobench. We even have partners that are contributing to physical AI, dexterity benchmarks. How do you measure the dexterity of a robot, for example? Like how do you benchmark that? Compare
Yeah.
one to the other. So there's a lot of effort being put into those things. And so our community is definitely heavily involved in that. And like I said, we contribute to those efforts, but we don't as a community publish benchmarks because then once you publish them, you have to enforce them and all that stuff. And we're not in it. Like I said, we're not the benchmark police, but the
Right.
ML Perf folks, they're the benchmark police. So we're happy to help them do that. But yeah, so as we see new tech out there, we're going to see more and more fine grained benchmarks to help people decide. Yeah, at the end of the day, it's not always like what's the higher score. It's really what's the right fit.
Right.
um,
Right.
like you said, you're building something. Like I'm building a thing for agriculture. I'm building a drone to like find weeds in a field and zap them with lasers. I don't know. I'm just making that up. Okay, so what do I need? So there's like obviously power consumption is big, weight, the battery life, the accuracy, so for each one of these solutions, it's not just who's the fastest benchmark. It's really what's the right fit of tech,
Right.
for that
Absolutely.
solution.
Yeah.
So,
Absolutely. And I love one of the lines you mentioned earlier is, let the thousand flowers bloom and, see what happens. And I particularly love how the AGI Foundation is working with all kinds of companies. They're chip makers, they're, like you said, these compiler folks, they're solution providers, and so on. But it does such a good job at being neutral across all of these companies and not really, being biased towards any one particular technology, one architecture, one solution provider, so on. Is there a very deliberate effort behind this, or is it just it comes naturally based on, the mission that the foundation has?
well, I mean, no, we do try to make sure that we are product neutral. We are about the success of Edge AI and the acceleration of that. And as you said, it's like and I say sensors to servers or metal to cloud, and from like pre-seed to big tech. There's that. If you plotted it, there's this very interesting space that we occupy, and also it's a team sport, right? You have to work with other partners to make this stuff work, and that's why we bring in software providers, solution providers, semiconductor providers, device builders, because you need to, when you deploy a solution, you need all those things to work together.
Yeah,
And so we try to cultivate that. And part of that is, everyone needs to keep an open mind about what's new and what's hot and what's interesting. And so we are a product neutral org. So like, for example, we just launched our Edge AI fundamentals online learning platform. You can certify your knowledge at different levels. We started with this Edge AI Fundamentals 100 level. It's product neutral, so we don't talk about products in there. And we're going to have more and more of those, so people can get educated in more of a neutral, what I call Edge AI literacy, neutral environment. And then you can, sure, you'll jump into your Qualcomm Dragonwing training or your Intel Open Edge training, and that's totally cool, but for us as an organization, and also making sure there's room, right? We need room for startups to show up. It's not just the big dogs all the time. So we
right,
have to try to,
right.
you know, keep it neutral. Everyone shows up, and we work together. That's the
Yeah,
goal.
as they
Well,
say, it takes a village to deploy an edge AI solution. So it's all about
that's
collaboration and, yeah, not about competition per se. Um,
right.
so with the last few minutes remaining, I
Hmm.
want to leave you with this question: Is what would you say to the next generation of students, AGI enthusiasts,
Hmm.
young people who are just entering into the industry and are very intrigued or curious about learning about AGI more? What is something that they should focus on? How can they upskill themselves? What are some good resources for them to get their feet wet and start
Yeah.
exploring AGI?
One of the things we did recently is we collected a bunch of resources at edgeaifoundation.org/learn. So if they go to our website and you can hit the learn button or go to that URL, there's a great collection of resources. So as I mentioned, we have our new Edge AI fundamentals online there. We have links to lots of university resources and learning resources. There's a lot of online learning out there. Um, there's a lot of stuff on YouTube to learn. So there's lots of places to build a lot of expertise very quickly in the space. We have a Discord server. It's thousands of developers on there talking about projects and stuff. So I would say for anyone who's interested in kind of putting a toe in the water, yeah, jump in. The water's fine. And if you go to that learn page, that's a good place to start. To sort of figure out who's doing what and how to get more educated. But it's a great time to get more educated in the space because there's the demand is just growing like crazy, and finding engineers that can understand AI and embedded software, that combination, or product managers and other people that just kind of know this space is it's a great way to build a career. And we also have on our YouTube channel the Edge AI Career Series, so people can look at that. It's a set of conversations we have about building your career with hiring managers and other folks like that too. So if you're into it, I mean, there's no limit to how successful you can be.
Absolutely. And the Edge AI Foundation, like you just said, is doing a great job on creating a lot of resources, putting out educational content for the community. So I'll leave some links about the Edge AI Foundation in the description so anyone who's interested can visit those links. Thank you so
Awesome.
much for your time, Pete. It was an absolute pleasure speaking with you, discussing some of
Yeah.
the trends around Edge AI.
Sounds good. No, it's good to chat again.
Yeah, thank
Take
you.
care.
And thank you to all the listeners today as well. If you want to learn more
Thanks.
about Ambient Scientific, I'll leave a link about our energy aware AI processors as well. So you can learn more about how we are playing our role in making Edge AI a possibility for the future.